So in my previous video, I have explained you about the standard structure of AX4, and also I have explained about the deviations, right? And I have asked you about the what are the molecular shape of these two cases. Here the thing is that, see, how can we draw the structure of this thing? Here, uh, nitrogen is having how many valency electrons? 5, right? 1, 2, 3, 4, 5. So there are 3 hydrogens, so make a 3 bonds with the hydrogen and 1 lone pair. So how many bond pairs are there? 3, and 1 lone pair is there. So overall 4 electron pairs are there for this also. So for this also the electron geometry is still the same, which is tetrahedral, but molecular geometry will be different. See, in case of molecular geometry, what we'll do, we'll describe the shape of the molecule based on the positions of the atoms. Like how can we draw this structure? Nitrogen, 1 bond with this thing, and 1 lone pair, right? The shape of the this molecule is what? Trigonal, pyramidal. And in case of this water molecule, how can we draw the water? Like oxygen is having 6 lone pairs, right? And there are 2 hydrogens, make 2 bonds. So how many bond pairs are there? 2 bond pairs. And how many lone pairs? Sorry, this is 2. So how many lone pairs are there? 2 lone pairs. So how can we draw the structure? This is somewhat like this. Here the electron geometry for this also still the same, tetrahedral, but molecular geometry is what? We'll consider only the position of atoms. So here the shape, how it is looking, it is looking like V or bent, है ना? So V or bent shape. For this diagonal, pyramidal. So I hope you have understood. It is a bit messy, but yeah, I hope you have understood the topics. See, here are the 3 cases. One is standard structure, which is having 4 bond pairs, and the electron geometry, molecular geometry, both are same, which is tetrahedral. And in case of having lone pairs, which if it contains 1 lone pair, the molecular geometry is diagonal, pyramidal. And one more thing is that due to the repulsions of these lone pairs, the angle between these bond pairs will decrease, which will be generally lesser than this actual angle. So I hope you have understood this topic. And yeah, thank you. Take care of yourself and bye.